Hi guys, so I forgot to record our video for this particular lesson. So let's have a look-see on that. This lesson is 10.1, properties of dilations. Okay, so first off, some vocabulary. A dilation is simply a change in size with multiplication. Okay, that's all that we're looking at. So dilation is simply a change in size with multiplication. We have a center of dilation, which is the point from which the size changes. In your case, it is always going to be a 0, 0. Technically, it does not have to be a 0, 0. It could be a different one. That would be perfectly fine. We have two types of dilations. We have an enlargement, which is a dilation that becomes bigger. So the shape becomes larger. And we have a reduction. That happens when the shape becomes smaller. Now, there's a couple of things to understand here. When it is in enlargement, the number we multiply by, is larger than 1. Is larger than 1. And when it is a reduction, the number we multiply by is smaller than 1. Okay, so we have an enlargement, which is larger than 1 because the shape is getting bigger, and a reduction, which is smaller than 1 because the shape is getting smaller. Last word we have in this is, last definition we have in this is for a scale factor. Factor means multiply. Scale means how much larger, how much smaller. So a scale factor is what we multiplied by to get the dilation. All right, so that is our scale factor. It's just what we multiplied by to get our dilation. Okay, so let's look at a couple of things to start with. I'm going to take you through some examples. All right, so we're starting out with this shape right here, this rectangle. It is 2 centimeters by 10 centimeters. I am going to dilate this by a factor of 3. I'm going to dilate by a factor of 3. So literally that means that what I am going to do is I am going to multiply each value I am given by the 3. Okay, so I'm going to multiply each of them by the 3. In this case, I end up with 2 times 3, which is equal to 6 centimeters. And I have 2 times 10, which is equal to 20 centimeters. So my new one is going to be, it's going to look like this. And our size is going to be 6 centimeters by 20. Oh, sorry. Why did I do that? That's not by, oh my word. Okay, it's by 30 centimeters. Let me go back and fix that one. So it's just a sec. All right, there we go. I fixed it. So our new rectangle, our dilation, is 6 centimeters by 30 centimeters. In this case, I multiplied by a 3, which is larger than 1, so it was an enlargement for my dilation. Let me flip on to the next page to show you a reduction in dilation. So for this particular one, I have a 15-inch by a 10-inch rectangle this time. And I am going to dilate by 0.2. Okay. So that means that I will multiply all values by 0.2, 2/10. And so I end up with a 15 times 0.2, which equals 15 times 0.2. 15 times 0.2. 3. And 10 times 0.2 equals 10 times 0.2 equals 2. And these are both going to be inches. Sorry, I need to put in my inches there. So my new shape looks like this. And it is 3 inches by 2 inches. This one, because it was a value less than 1, ended up dilating to a smaller one. So it ended up reduction. It ended up being a reduction for our dilation. This one works with the side lengths, like what I just showed you right here. It can also work with the coordinates. So if you are given the coordinates, so let me go. If you are given a coordinate plane, you can use the X and Y coordinates to make your dilation. You multiply each X and Y by the number, by the factor of dilation. And then regraph it. Okay. So that's what we do when we are given ones that are in a coordinate plane. We do exactly the same thing, except we multiply the X and the Y's by the factor of dilation, and then we regraph them. I'll go over to an example on the coordinate plane in just a second, but let me first write this up over here before we do that. Let's talk about, we need to find the dilation for just a sec. So in order to find a dilation, you need to divide the end, that would be the prime, by the beginning. That would be the original. Okay. Whatever that is, is the dilation. Now, remember a couple of things. For dilation, we have several things that are true. First thing is they are always proportional. If it is not proportional, it is not a dilation. They are always the same shape. They always have the same angles. Oh, one other thing. They're always proportional. They're always the same shape. They always have the same angles. They always have the same orientation. Okay, so these four things are true for all of them. You want me to put it into a different color? I'll put it into a different color. Let's put it into blue. Okay, so that is always true for all of these. They're always proportional. They always are always the same shape. They always have the same angles. They always have the same orientation. We can use that when we're solving this. And if any of these is not true, if it's different shape, if it's a different set of angles, if it changed what it's doing, then it's not just a dilation. They did something else to it too. All right, so let's do one of these on a coordinate plane and have a look-see at it. All right, so here is my starting shape, A, B, C, D. A is at 0.2, 6. B is at 4, 4. C is at 0.1, -2. D is at 2, 3. All right, so that's my points that I'm starting out with. I am going to do a dilation of, let's see, let's go with a dilation of 4. All right, sorry guys. I sat there and I went forward a little bit and I realized that I can't actually do a dilation factor of 3. I do not have enough space. So we are instead going to be doing a dilation factor of 2. The first thing that I do is I have my point 2, 6. So I go 2 times 2 for the X, 6 times 2 for the Y, which then gives me 4, 12. And then just a sec. Here we go. For B, I have 4 times 2 for the X, 4 times 2 for the Y, which gives me 8, 8. For the C, I have -1 times 2 for the X, -2 times 2 for the Y, which gives me a -2, -4. For letter D, I have a -2 times 2 for the X, a 3 times 2 for the Y, which gives me a -4, 6. Then I come over here and I put in point at 4, 12, point at 8, 8, point at -2, -4, and a point at -4, 6. I connect all the dots and add in my letters. So A prime, B prime, C prime, D prime, and then the primes to go with each of them. Okay. So that is what you do when you take the dilation factor, when they give it to you, and then you put it onto it. You can go the opposite direction, of course. That is, you divide the X from the X, you divide the Y from the Y. It should end up equaling out to exactly the same amount, because if I multiply up by the same amount, I should be dividing down by the same amount. Yeah. So that should work out just fine. All right. I do believe that that's everything that we need as far as notes are concerned. Everything else is inside the book. So talk to you guys later. Bye.